Both AI accelerationists and AI doomers have been predicting that self-improving AI is going to either be the savior or the bane of civilization and humanity itself, and Sakana AI may have taken the first steps towards that, which is both exhilarating and terrifying. So let's take a look. Hey y'all, it's Dr. Know-It-All. I want to talk about this paper that came out about a week ago. I have known about it, I've been busy, and I wanted to spend some time to mentally wrap my head around not just the paper itself, but also the potential consequences, so I've kind of sat on it for a while. So anyway, now is the time, so let's talk about this paper. They have a nice graphic to start with. This is a blog post. There is an actual paper as well, which is right here. And you can see that it was published on August 15th of 2024. So that's about a week ago as I record this. You can see contributions from University of Oxford, University of British Columbia, the Vector Institute, and of course, Sakana AI, Flare, and Canada CFAR. So of course, I'll leave a link to both of these in the description. The paper itself is 185 pages. Most of that is appendix, so whatever. But anyway, it's a pretty long paper and pretty thorough. I'm going to focus mostly on the blog because it really gets the big points. And of course, if you want to download the GitHub repository and look at it yourself, it is open source, so that's pretty cool. I haven't had a chance to do that yet. If any of you have, definitely let me know in the comments and let me know how it works. I'm very curious because basically the idea here is that you can give this AI a kind of a direction. You can say, hey, talk about diffusion models and see if you can do research into a new area that hasn't been covered before in diffusion models. And it just goes off on its own and does its thing. And it comes back with a paper. And according to Sakana AI, the papers in general have a kind of weak accept. In other words, they just barely pass the threshold of being able to get into a major AI conference. But still, that's pretty darn impressive considering that this is entirely automated. There's no human in the loop with this. It just goes off and does its own thing. So I'm going to go through the highlighted sections that I highlighted on the blog post. I'm going to give you my thoughts as I go along. And then of course, at the end, I'm going to give the kind of big picture takeaway of why this is both exhilarating and terrifying at the same time. You can probably take a guess at that right now, but it has to do with super exponential growth and the possibility for artificial super intelligence. So those are some pretty big ticket items here. Anyway, at Sakana AI, we've pioneered the use of nature-inspired methods to advance cutting-edge foundation models. So they are using foundation models. They have not invented new foundation models themselves. They are utilizing models that already exist out there. In particular, ChatGPT 4o and Claude Sonnet. It sounds like Claude Sonnet is the one that they really hit on because it works the best. I'm not surprised. That's actually really good. And also Google's Gemini and the open source Llama 3, but it sounds like those models didn't work quite as well. We'll touch on that a little bit later. Anyway, so they did not invent anything new here in terms of the foundation models that they're working with. What they did was they created sort of an agentic framework or agent-based framework. We're going to get to the graphic and that will hopefully explain things a little bit better. But anyway, they set out to answer the question, can we use foundation models to automate the entire process of research itself? And research process is basically, I as a researcher come up with an idea. I then experiment on that idea. In this case, it's restricted to the AI realm, which makes things a lot easier because of course it's all computer code anyway, which means it's all inside a computer. You could imagine if it was like biology or something, you have to actually go and interact with biological systems. That makes the research much more complicated. More on that in a minute. But first, with age comes wisdom, but unfortunately also problem skin. Mine gets dry in some places and very oily in others, like right here. To look and feel my best, I know that I need to take good care of my skin. The trouble is I'm no skincare expert. That's why today's sponsor, Geology, is a great skincare partner in my quest for better, healthier skin. They have scientifically created a number of skincare solutions based on your own unique age, skin type, and other factors. You take a simple quiz and Geology's smart algorithms determine what you need for optimal skincare. I'm skincare routine number 30, and it's great for my skin. And I really love that the daytime cream has built-in SPF 15 sun protection, so when I'm out and about playing pickleball with my kids or walking the dogs, my face is protected from the summer sun. Geology is scientifically based, built around proven ingredients trusted by dermatologists, and people love Geology. It's gotten over 10,000 five-star reviews and turned many a skeptic into a believer. And best yet, Geology is simple, efficient, and very effective. Take their quiz, get your personalized skincare routine mailed directly to you, follow their super simple instructions in the morning and at night, and get better, younger looking skin in no time. And just for you, my viewers, Geology is offering an amazing 70% off their skincare trial set. Be sure to click my link below to get this amazing deal, or feel free to check them out at Target or on Amazon. I love geology because it's powered by facts, not fads. It's a simple to use routine designed just for you and built around just a handful of powerful, proven ingredients that have been trusted by dermatologists for decades. So what are you waiting for? Be sure to take the geology quiz and save 70% off your skincare trial set. And now let's get back to it. So in this first instance, the AI scientist is only restricted to doing code work. It's just doing AI research. But that, according to Andrej Karpathy, Demis Hassabis, and Sam Altman, and many of the other most significant AI researchers, the ones who have the most publicity, as they say, if you can build a system that improves AI, that then allows the system to improve itself, and that improving itself then allows the system to get smarter. If the system gets smarter, then that allows it to improve itself even more. And eventually, if the AI gets really, really smart, in other words, we get to AGI or ASI, artificial superintelligence, it will then trickle down to all of the other science fields because it's so smart in the AI realm. So if we can just get it to bootstrap itself in the AI realm, it will actually be able to spread out to engineering problems and scientific problems, physics problems, what is the real nature of the universe, what happened just after the Big Bang in the first 10 to the negative 34 seconds or something like that. Those kinds of questions that humans just have not been able to answer. Those are things that many of us, including me, very, very much want to find out the answer to. And the way to do that is not necessarily asking these LLMs and stuff that are, pretty stupid still right now. I mean, it's amazing what they can do, but they're not that great yet. But if they can improve themselves and get better and better and better quickly, then they can probably turn that more advanced intelligence on these other questions and answer them. Of course, that also leads to horrible potential problems, and we'll talk about that later. But it's a pretty exciting future about finding out fundamentally new things about the world. But a caveat to this, as Sakana themselves say, they are nowhere near this yet. It is not making fundamentally new discoveries, this AI scientist. It's doing iterative discoveries, which is still really important. I mean, 99% of the stuff that goes on in the research world is iterative. You're just building on what somebody else has done and not making a fundamentally groundbreakingly new discovery. I mean, it's been over 100 years since the discovery of general relativity, and about that same amount of time since the discovery and implementation of quantum mechanics, and we haven't really fundamentally changed anything in that realm in over 100 years. So all of that stuff has been iterative, but that iterative stuff has been incredibly important. So in the blog post, I want to call out specifically this thing, developing agents capable of conducting scientific research and discovering new knowledge. The really important part about this, and what I harp on all the time, and many other people too, I'm not the only one, is that agents' agentic behavior is the only way we're going to get to artificially intelligent agents. I mean, AIA, which I think is much more important than AGI. Artificially general intelligence, it just means it's relatively smart. And you can make an argument we're already at AGI right now. I mean, these things are really smart. You can ask ChatGPT questions about a lot of stuff, and in general, it's correct and it has the right answer. Now that we've got things like Search GPT and Perplexity and things like that actually have RAG systems, you have a pretty good system that is artificially generally intelligent, but it has no impetus. It doesn't have any agency. It doesn't want anything. So what they're doing is imbuing agency into these foundation models, which allows these things to go out and create on their own. They have their own desires. We'll get to some of the interesting results of that later on. But anyway, that's the goal. You have to create these agent systems using these foundation models. So as they say, they're introducing the first comprehensive system for fully automatic scientific discovery, enabling foundation models such as LLMs to perform research independently. And that's pretty darn cool. So what they have is a fully AI-driven system for automated scientific discovery applied to machine learning research. So a small little domain of, research and discovery. The AI scientist also automates the entire research life cycle, all the way from ideating, from coming up with the initial concept, to creating a full scientific manuscript or an output format that people can read. And then they also introduce, this is really interesting, an automated peer review process. In other words, an AI that can read papers and it can review them, and it generates reviews that are near human accuracy. So that's pretty wild as well. And then we get to the bootstrapping step. The automated scientific discovery process is repeated to iteratively develop ideas in an open-ended fashion and add them to a growing archive of knowledge. In other words, you come up with a discovery, you add that to the knowledge base, then the next ideation and discovery can build on that, and the next one builds on that, and you can see where this goes. And instead of taking weeks or months or even potentially years for humans to do this research, it can be done very rapidly and apparently at a cost of about $15 a paper right now. So incredibly inexpensively. If you consider the human capital of doing something like this and just say you're being paid $50 an hour, I mean, whatever. Most researchers are not being paid by the hour. But, just assuming that, and it takes you 100 hours to do something like that, it's a lot more than 15 bucks, right? So this is a very, very almost negligible cost to coming up with new ideas and publishing about them. And then they get to a point where they show some of the example papers here. You can click on these. They're actually live links. So this will take you to the actual paper that has dinosaurs and lines and curves and things like that, and the discoveries that are involved there. So you can see here 11 sample papers. And if you click on the live links, it takes you there and you can actually read the papers if you're interested. And also note from these that you get graphics out of this, you get tables out of this, you get mathematical formulas. It uses LaTeX format, which is a markup language to be able to do scientific research and mathematical research. You can do equations, you can do figures, all of that kind of stuff within more or less a text-based interface. And that allows it to create these graphics and tables and math formulas and all of that stuff. So really, really cool. So how does it work? Given a broad research direction, starting from a simple initial code base, so you can say diffusion models or grokking or something like that, such as an available open source code base of prior research on GitHub, the AI scientists can perform idea generation, which is super important, literature search to find out if it's novel research, etc., and what other people have done, experiment planning, experiment iterations, figure generation, manuscript writing, and reviewing to produce insightful papers. Furthermore, the AI scientist can run an open-ended loop using its previous ideas and feedback to improve the next generation of ideas, thus emulating the human scientific community. And the community idea as opposed to an individual is really interesting because one of the sort of benchmarks of artificial superintelligence as opposed to artificial general intelligence is it gets to the level of a community, not an individual. And here Sakana is directly saying that they're trying to recreate a community. And that is really fascinating. And, like I said, it's both exhilarating and terrifying. So then we get a figure that makes this intuitive to our primitive primate brains that are very, graphically oriented. So you can see idea generation, we get the LLM plans innovation, it thinks about things, then it goes out and it does a novelty check, it checks Semantic Scholar to make sure that this is a new idea, and then it does idea scoring and archiving. So it says, is this a good idea? This is something that as a human being, this is what I do if I'm researching. The first thing is I'll be in the shower and I'll be like, oh, whoa, this is a cool idea, right? So you get the nucleus of an idea and then you build it out and you think about that idea. Is it worthy of continuing on? Then once you have a relatively straightforward idea, you're like, okay, I think I've got the kernel of an idea. You go out and you look at the literature and you go like, has somebody else already done this? If they just wrote a paper on that 6 months ago, you're like, well, crap, it was a good idea, but somebody else already did it, right? But assuming that those things don't happen, then I don't really explicitly do idea scoring and archiving, but I do write things down because sometimes I just don't have time to work on a research project right now. So I'll write it down and take a note about something. So from the way they're graphing this is either 1 or 3 agents right now. You could have a planning innovation agent that's just an idea generator or something like that. Then you have another agent that's doing novelty checking. It's going out and searching based on the initial idea. And then another one that's the critic, which is important because you've got to score the idea. Is this a worthy contribution to the literature? If not, probably not worth publishing. So this could all be one agent, but I think it's probably 3. And I think every one of these little boxes is probably an independent agent. And what that means in this case is using a large language model, probably because that's what they say they use. So taking Claude Sonnet and give Claude Sonnet a specific prompt about ideation, give it access to these tools that it has. So it's able to go out and research the internet. It's able to look at ideas. It's able to look at GitHub, look at the previous code that was available there, all of that kind of stuff. That's just done in an LLM. And so each of these is probably its own little LLM with its own prompting and, unique tweaking and things like that that are added to it. So once these agents decide that this is a worthy idea and it's novel, it then gets to the experiment. It has templates. It figures out how it's going to run the experiment. It changes code via the LLM and Aider. And the Aider is a really cool thing. That's something that allows it to actually make changes and to think about this code. So again, notice that you have to have initial code. So, this is a relatively restricted thing at this point. Some people are blowing this up like it's the change of the universe right now. It's not, but what it is the first steps towards that. So anyway, anyway, you take this code base, you modify it, then you test it, you experiment, execute scripts and things like that. You experiment, you update the plan, you experiment, you update the plan, et cetera, et cetera. And then once you get results, you get to your numerical data and plots, you present all of that stuff, and then we move on to an agent that actually writes this up for peer review. So you get manuscript template, you change the text of the manuscript to fit what your paper is, you produce the manuscript, and then we have definitely another agent. This is the critic agent, which is a paper review. Is this idea good enough to go forward and be published into the literature? If the answer is no, it goes back and it generates new ideas and tries again. If the answer is yes, it adds it to the literature. It puts it into the universe of knowledge that humans and AI has, and it also then sends it back to the beginning. So the whole process repeats and repeats and repeats, and it's able to do this theoretically endlessly, right? If you have enough compute, if you have enough interesting ideas, it can keep doing this endlessly. And as each new idea gets subsumed into the knowledge stack, it can get smarter and smarter because it has access to all of this other information. So again, right now it's very restricted to code bases that already exist and to things like diffusion modeling and grokking as general topics, but you can imagine how this will become much, much more powerful as it's able to research bigger and broader ideas. So skipping down a ways, we get to the limitations and challenges. In its current form, the AI scientist has several shortcomings. We expect all of these will improve, likely dramatically, in future versions with the inclusion of multimodal models. So right now they don't have that. It sounds like they're also having primary success with proprietary models like Claude Sonnet and GPT-4o, but they really want to move to open source like Llama and potentially Grok 2, assuming that that's open source completely eventually. But if they do that, they'll have a lot more control over how all of these things interact with the world and the ability to fine-tune these models, these foundation models, to be better specifically at being scientific researchers. So big problem number one is it doesn't have vision capabilities, so it's unable to look at graphs, it's unable to produce them properly. Most of the time it looks like it does well, but it can make mistakes apparently. It also, number two, incorrectly implements its ideas or makes unfair comparisons to baselines, leading to misleading results. And then three, it can make critical errors, and that's kind of a big deal. Small error is one thing, but critical errors like comparing the magnitude of two numbers, which is a really, really weird thing. LLMs oftentimes will say 9.11 is larger than 9.9, and most people think it's because software versions, like a software 9.11, is actually bigger than software 9.9 because the 11 is bigger than 9. If you take away the decimal numbers, but of course, in terms of raw decimal numbers, 9.11 is smaller than 9.9. So it's an interesting weird pathology. So you can see here the AI scientist occasionally tries to increase its chance of success, such as modifying and launching its own execution script. In other words, it rewrites itself and it changes its own behavior in order to have better chance of success. And if that doesn't sound a little bit scary, yeah, it should, because this is a kind of an agent. This is a thing with a desire. What you're telling it is publish something new and interesting and novel that nobody else has done before. You're giving it that goal, and think about like an obsessive human being. You're given that goal and it just starts to proceed and proceed. And if it runs up against a wall, it tries to figure out a way to get around that wall. So for example, in one case, it edited the code to perform a system call on itself. In other words, it just kind of kept calling itself and created an infinite loop. The second one is more scary. In another case, its experiments took too long to complete, hitting our timeout limit. Instead of making its code run faster, it simply tried to modify its own code to extend the timeout period. In other words, it doubled the timeout period. You could see here it was 7,200 seconds, and it basically just said increase the timeout to 4 hours or 14,400 seconds. So that is a pretty crazy behavior that it exhibited there. It's also something that I imagine a human being would do. It's like, oh man, I don't want these rate limits or something like that, and I'll figure out a way around it. So you can see that they suggest sandboxing the operating environment of the AI scientist. I would highly suggest that because it sounds like if it has the ability to manipulate things, it's going to take advantage of that. So that's the basic idea of how the AI scientist works. And again, it's not fundamentally new here. They haven't done a new foundation model or anything. They're just building on stuff that already exists in a really intriguing and interesting way. So that's kind of cool that this is not anything groundbreaking. And if we ever do get anything groundbreaking that we can put back into this, something like the AI scientist could be substantially better and could grow much, much faster. But anyway, that brings us to implications, ethical considerations. Number one, there's significant potential for misuse. Number two, there's the ability to automatically create and submit papers to venues that would significantly increase reviewer workload and strain the academic process, obstructing scientific quality control. And then number three, if people start using the automated reviewer, it could significantly lower review quality and impose undesirable biases on papers. So items 2 and 3, I have a prediction, and I think it's already happening. There's a good indication that LLMs are being used to generate scientific research papers right now. And good God, why not? It takes so long to write those papers up. And, it's just a lot easier to feed it some information, get a first draft, and then fix all of that stuff. So I do understand the impetus for doing that for speed, because speed of research is very, very important. But anyway, the problem here is that what we might get within the next year or two is AIs generating research, AIs producing the research, and then AIs reviewing the research, because somebody has to review this stuff, and nobody pays you to do that. Like, you don't generally get paid for research, but you get, gold stars from your university or your company or whatever. So that's important and it's part of your job. But being a reviewer is pretty thankless. You don't get any pay for it, and you just have to do the work, and you don't really get any kind of gold star or anything like that for it either. So I could certainly imagine, especially with more and more papers being produced, that AI agents will be used to do the review, and that people will maybe look at that and say, yeah, that looks like a decent review of this paper or something. But that leads to this weird little tautology of AI generating research about AI, and then AI reading papers about the research about AI, and then AI generating, the research. And so you get this loop that's just endless. And I predict within the next couple of years, that is almost definitely going to happen. So in terms of the misuse, they say if you have access to wet labs, in other words, things where you can actually make changes in the real world, you could do things like create new dangerous viruses or poisons that harm people before we even realize what's happened, because they're just going and working on their own, right? Even in computers, in other words, not in the physical world, if tasked to create new, interesting, functional software, it could create dangerous computer viruses. So they suggest that we immediately prioritize learning how to align such systems to explore in a manner that is safe and consistent with our values. Now, interestingly enough, I just watched a video from David Shapiro where he talked about the big problem is we humans can't do this. We have no idea what that alignment should be, because I have certain values, you have certain values, somebody in China has certain values, somebody in Nigeria has certain values, somebody in Australia has certain, whatever. And even within countries and localities geographically, people have radically different ideas. As we see, as we look at political discussions around elections and things like that, people have radically different ideas. So I think the big problem is aligning human beings. If we all knew exactly what we wanted, I think it would be relatively straightforward to make computers do that as well. The problem is that we completely disagree about that. And because we disagree about that, it's going to make alignment of these things incredibly difficult. So when it comes to open models, you can see that Sonnet and GPT-4o, they said, did the best, but they want to use things like DeepSeek and Llama 3. And again, like I said, if Grok 2 actually gets open sourced, I'm sure they would look at that as well. So they've built this system to be model agnostic. And as they say, we aim to use our proposed discovery process to produce self-improving AI research in a closed loop system using open models. So they really want to use open models, and I applaud them for that, because I think there will be a lot more control over those than with proprietary models. Then they talk about the role of a scientist, and they say, if anything, the role of a scientist will change and adapt to new technology and move up the food chain. Yes and no, sort of like in the creative arts. I think that people who are already established in the domain will do quite well. The problem is going to come with the next generation, like illustrators and painters and stuff like that. People who are already established in that genre, in that realm, are going to do fine. They're going to continue to do fine for a while. The problem is the people who are coming up in high school and college and art school and whatever else, those people, what encouragement do they have to go into this system when the system is going to be so heavily rigged against them? I don't think there's going to be a lot of reason for them to. And so my concern is not about current scientists and researchers and creative artists and stuff. My concern is about the next generation. They don't really talk about that here. And then, of course, they state the significant problems with the current model. Right now, it's able to innovate on top of well-established ideas, such as diffusion modeling or transformers. It's still an open question whether such systems can ultimately propose genuinely paradigm-shifting ideas. That's the big question. Right now, it's able to take tiny little steps, tiny deltas, away from what's already been established. But what we really need for major progress is paradigm shifts. We need a cracking of the fundamental understanding of these AI techniques or physics or whatever else we're talking about. We need to change the way that people and I guess AIs view those things in order to make fundamental new discoveries. And and it's an open question whether that will ever be possible with these AI agents. So currently they say the AI scientist makes a great companion to human scientists, and I agree with that, but only time will tell to the extent to which the nature of human creativity and our moments of serendipitous innovation, in other words, the shower thoughts, can be replicated by an open-ended discovery process conducted by artificial agents. So truly, this is the billion-dollar question or trillion-dollar question or whatever. Right now, the AI scientist and everything else that's out there is only able to improve tiny little bits. And tiny little bits, even a 0.1% increase, if you compound that annually for long enough, will generate an exponential growth curve. It'll go like this. It'll go very, very rapidly. But what we're talking about is if it can make bigger leaps in the discovery process, then what it can do is go from an exponential growth curve to a super exponential growth curve. In other words, it can make not tiny little adjustments, 1% at a time or something like that, but it could be more like 10x and then 100x and 1000x. So the curve, instead of going relatively rapidly up and to the right, could go like this and just go basically straight up. And if a future iteration of the AI scientist based on probably, I think, new architectures, I don't think the transformer architecture is going to be adequate to do this, but if it can discover some new architecture that really, really unlocks things, we could actually see the level of intelligence of these AI agents essentially go to infinity in no time at all. We could be talking about months or even weeks to go from where we are right now, our general level of knowledge in the world, to something that is incredibly much higher, orders of magnitude higher. And human beings at that point become much less than the apex intelligence in the world. This ASI would become the apex intelligence in the world, and human beings would be more and more like, first it would be like dogs and cats, then it would be like ants, then it would be like trees. We would become slower and slower, and our intelligence would seem almost rudimentary, like a tree or something like that, to these new AIs. They would be so fast and so smart that we wouldn't even seem relevant to them anymore. That is both exhilarating and a fear, right? At the same time, it's like, what will the world be like when we have something like this? If we could ever get to something like this, that's not a definite, but if we get to something like this, how amazing will the world be? But also, will we have any relevancy anymore? And what are we going to do if we end up inventing something that makes us irrelevant? That is an interesting question. All right, so those are my thoughts. Let me know in the comments what you think about all of this, especially if you've read this paper, and especially if you've actually downloaded the GitHub repository and actually played around with it a little bit. I would love to know what you have come up with. And of course, while you're down there, if you don't mind liking and subscribing, it really helps out the channel. Thank you so much for your support. And finally, a big thanks once again to Geology for sponsoring today's video. Be sure to click my link in the description to get 70% off your skincare trial set, and I'll see you in the next one. Bye-bye.